morning friends, I am Vaishakhi Shah from LJ Institute of Engineering and Technology. In last lecture we started our module which is called dimensional analysis. Now first of all, what do you mean by dimensional analysis? So dimensional analysis is a method from which you can convert any unit to another unit. You can change any one unit into another unit that we discussed in our last lecture. Now there are two methods for dimensional analysis, and first is Rayleigh method, second is Buckingham pi theorem method. Now in today's lecture we will discuss Rayleigh method for dimensional analysis. So let's start with Rayleigh method. So in Rayleigh method, clearly it is a functional relationship between variables is expressed in the form of exponential relation which must be dimensionally homogeneous. Now it means in equation, this is in form of word, but in equation form you can say that if y, any alphabet we are taking here y, here y is a function of independent variable which is not dependent on any other function, and if you are selecting y as an independent variable, then x1, x2, x3 up to x raised to n is written as y equals to function of x1, x2, x3 up to xn. Here y is an independent variable, so y is a function of x1, x2, x3 up to xn. In exponential form, here we mentioned the exponential form. So in exponential form it is written as y equals to phi bracket x1 raised to a comma x2 raised to b comma x3 raised to c up to xn raised to z. In Rayleigh method, if y is a function of x1, x2, x3 up to xn, then in exponential form it is written like this: phi x1 raised to a, x2 raised to b, x3 raised to c up to xn raised to z. You can clearly understand this by example. So let's solve our first example by Rayleigh method. So in this method, the data given to you is the resisting force R of supersonic plane during flight can be considered as dependent upon length of the aircraft, which is L, velocity, which is V, air viscosity, which is mu, air density, which is rho, and bulk modulus of air, which is K. Now express the functional relationship between variables and the resisting force. Here the resisting force, which is R, that is dependent on length of aircraft, velocity of aircraft, air viscosity, air density, and bulk modulus of air. So that are your x1, x2, x3, x4 up to xn. So let's start. Here R is your resisting force. Now R dependent on length, velocity, viscosity, density, and bulk modulus of elasticity. So you can write down there R equals to function of L, V, mu, rho, K. Length, velocity, viscosity, density, and K, that is bulk modulus of elasticity, okay, which is written as R equals to A, that is your capital A, L raised to A, comma V raised to B. It is written as exponential form here: V raised to B, mu raised to C, rho raised to D, and K raised to E. In Rayleigh method, the variables are written in exponential form here, okay, where capital A is a non-dimensional constant. Remember that here capital A is non-dimensional constant. So, substituting power on both the sides of the equation, you get that, as we already discussed the powers of different quantities in our last lecture, that is in form of MLT. MLT. M indicates mass, L indicates length or distance, and T indicates time in second. So, this we already discussed in our last session, that MLT form, the different MLT form of different quantities. Now, here we apply the powers of MLT on both the sides of the equation. So, first of all, on the left hand side there is a R. R is your resisting force, and the equation of force in MLT form is M L T raised to minus 2 equals to A, which is your non-dimensional constant, L raised to A, L raised to A, which is in form of length, that is L raised to A. Second is velocity, which is meter per second. So, L T raised to minus 1. Now, third is your viscosity, mu, Newton second per meter square, which is written as M T raised to minus 1, L raised to minus 1 raised to C. And fourth is density, mass density rho, which is M L raised to minus 3 raised to D. And the last quantity, which is bulk modulus of elasticity, and its unit in form of MLT is M L raised to minus 1 T raised to minus 2 raised to E. Clear? Okay. In last lecture again we studied the basic quantities, that is M in form of MLT. So, please go and refer that quantities again for solving this example. Okay. Now, as we know that this is our equation in form of MLT on both sides. Clear? Now, equating the power of MLT on both the side. Now, we will equate the power of MLT on both the side. So, first of all, power of M, which is on left hand side, left hand write C on left hand side in the equation. What is power of M? Which is 1. So, 1 equals to, on the right hand side, the power of M, where first is C plus D plus E. On left hand side there is a power of M is 1, and on right hand side the power is C plus D plus E. Same power of L both the sides, then power of L on left hand side is 1, because there is M1 L1. So, power of L is 1. 1 equals to A plus B minus C. See the power in this equation on right hand side in this equation. So, first is A plus B plus minus C, because there is minus C in the form of mu, minus 3 into D, here minus 3 into D, and at last there is minus E. These are the power of L and both the sides. And lastly, power of T. Now, what is power of T on left hand side? Yes, it is minus 2, and power of T on right hand side is minus B minus C minus 2E. Clear? Okay. So, now moving forward in our example, since we know that the unknown phi are more than equation 3, So expressing A, B, C in terms of D and E. Here there are 5 unknowns and we have only 3 equations. So we can express ABC in the terms of D and E. So we already have this equation of MLT on both the side, power of M, power of L and power of T. Now we will replace ABC in the form of D and E. So here you can say that D equals to 1, here you are making D as your subject. In this equation, first make D as your subject. So D equals to 1 minus C minus E. In the equation of power of M, make D as your subject. So D equals to 1 minus C minus E. Now from second equation, make B as your subject, small b. So your equation of L, make B as your subject, so that become in equation of T, make B as your subject in your third equation, which is power of T. So that become B equals to 2 minus C minus 2E. Clear? Now the second equation, power of L, make A as your subject. So you have A minus B plus C plus 3D plus E. Now we have the two equations for B and D here. So place the value in the equation of B and D. So you get clearly, again we are placing the equations of B and D in the equation of A. So 1 minus 2, 1 minus bracket 2 minus C minus 2E plus C, okay, that 2 minus C minus 2E is the value equation for B, okay, plus C plus 3 into D, there is 3 into D. Now we know the equation for D, which is 1 minus C minus E. So 3 into 1 minus C minus E plus E. By solving the equation, you get the final equation by opening these brackets, which is 1 minus 2 plus C plus 2E plus C plus 3 minus 3C. Here we simply open the bracket, okay, minus 3C minus 3E plus E. So your final equation become 2 minus C. 2 minus C. Clear? By simplifying that, you get 2 minus C. Now substituting the value in equation 1. Now what is equation 1? This. We know that R is a function of L, V, mu, rho and K. So this is your equation number 1. A, L raised to A, V raised to B, mu raised to C, rho raised to D and K raised to E. Now substituting value of A, B, T in equation of 1. So you get that R equals to A. This is your A and L raised to A. Now what is the equation for A? 2 minus C. So A, L raised to 2 minus C, V raised to B. So B is 2 minus C minus 2E. Mu raised to C, rho raised to D, and we know the equation for D, which is 1 minus C minus E, and at last K raised to E, So your equation can be written as A, L square, V square into rho, L raised to minus C, the same powers you can written in a bracket, you can write in bracket L raised to minus C, V raised to minus C, mu raised to C and rho raised to minus C. and v raised to minus 2e, rho raised to minus e, k raised to e. Clear? Now, so you can write this equation as, by simplifying this equation, r equals to a rho L square V square, in bracket it is mu divided by rho L V raised to C, because it is in exponential form, that is a C. So, mu divided by rho V L raised to C. Okay, and next bracket it is written as K. This is your K upon, these are in minus, so K upon rho V square raised to E. Okay, clear? So, your final form you can write like this also, R equals to capital A rho L square V square phi, in bracket it is U upon rho V L into K upon rho V square. Clear? So, this is your final equation of final equation we solved by Rayleigh method. Clear? You can solve more examples by using this Rayleigh method. So, this is the procedure for solving the example based on Rayleigh method. So, there are some steps, we quickly discuss these steps, so you can solve any example by this method, where first write the MLT form of given data. We already uses these steps. We are in last example we already used these steps. So, we quickly revise that. First of all, write MLT in form of given data. Second, write the same equation in exponential form, which is raised to a, raised to b, raised to c, etc. Third, select suitable system of fundamental dimensions. Fourth, substitute dimensions of physical quantities. Substitute dimension of physical quantities. Fifth, apply dimensional homogeneity. Clear? That we applied, okay, in last example, dimensional homogeneity. The equate powers of different values on exponents. Substitute the value and simplify the expression. The ideal up to 3 independent variable can be used for 4. Clear? So, this is the procedure, the step-by-step procedure for solving any example by using Rayleigh method. Okay. So, done for the today. In next session, we will discuss Buckingham pi theorem method, which is also another method for dimensional analysis. Okay. Goodbye.